Hello everyone, today we are talking about math. Math is really important because math is the language of the science. To understand science, to understand my videos, you have to know particular representation and particular notation. One of them is d divided by dt. Let's write beside the d f of t or f prime t. Have you ever seen such a notations, by the way? If you're not, don't worry. This is the meaning of derivative. This is derivative notations. Okay, just derivative. What does that mean? Come on. That means that the rate of change of something. I don't know, depends on the context. But rate of change of something. I know this kind of theoretical and don't make sense in your mind. Let's try to give a concrete example. This is my road. It's my car. My drawing's really bad, by the way. Okay. Tire. Okay. My car has an initial velocity 3 km per hour. And my velocity is changing in time. As you know, most of the time in TV, you would hear that. Rate of change of velocity. Rate of change of velocity is 1 kilometer, kilometer per hour. Or rate of change of velocity is increasing. Let's write it in a better way. Increasing 1 kilometer per hour. Okay, what does that mean? So, in per hour, my velocity increase in 1 kilometer. So, let's write in a mathematical sense. At t equal to 0 hour, my velocity is equal to 3 kilometers per hour. That's initial velocity. That's not a problem. At t equal to 1 hour, my velocity is 3 plus 1 change per time, per hour, equal to 4 kilometers per hour. T equal to 2, V equal to 3 plus 1 plus 1. This is the new rate of change of 5 kilometers per hour. As you can see, there is a really good pattern. Let's show it. There's a distance 1, there's a distance 1, 2 in between each consistent hour. So my rate of change of velocity is 1, and my difference between the velocities is also 1. Okay. I hope that start to make sense to you, because this means that in 10 hours, my velocity become 13 kilometers. After 10 hours, actually. Because in per hour, my velocity increase 1. Let's try to write this situation in a mathematical equation. I'm sorry. Okay. Okay. I have such a function. Let's call this function f of t. F of t. What is my initial velocity? My initial velocity is 3. And when times goes, my velocity increase at the rate of 1. So I have t, right? At the end of this examination, this equation start to make sense in your mind, and you can write such equations. Okay, let's put the numbers. That's simple things again. T equal to 0, V, or f of 0 equal to 3. T equal to 1, f of 1 equal to 4. T equal to 2, f of 2 equal to 5. Okay, that makes sense. I'm looking at my data, and I'm looking at my data. That's fix, and fix. So I'm in correct pattern. Let's assume this is a function. At the beginning of this lecture, I showed to you df of t. Let's write it in a better way. Oh, that's become more horrible. Okay, whatever. df of t divided by dt, or f prime t. We know the function. Let's try to write in our notation. Let's try to find rate of change of this function at times go. Okay. I know some of you could find the answer right now, but let's write it in mathematical sense. Actually, let's give a physical explanation again. What is the rate of change of this function? It's easy. When t equals to 0, it's 3. When t equals to 1, it's 4. Take the difference between them, it's 1. Okay? But we have to make consistent this data. So let's look at the t equal to 2, f of 2 equal to 5. The difference again 1. So rate of change is 1. Okay? In per hour, but remember that per hour, per time. Okay, let's take or f prime t equal to. By the way, this is the polynomial function. In polynomial function, we have 3 times t equal to 0. By the way, this is 1. Plus, plus t over 1. Okay, t prime 1. No, not prime, t over 1. So when I take the derivative, let's write that. I will put this first part in front of the number. And I decrease this upper function. So what does that mean? My f of t is 3 times 0 times t minus 1, let's presume, and we subtract the 1 to the t function, and plus, let's add them, plus 1 times, I put the 1 times t over 0. Okay. So what does that mean? That's mean 1. What does that mean? That is the 0. So my f of t equal to 0 plus 1, 1. So my rate of change of this function means that is 1. Is it make sense to our car example? Rate of change of velocity is increasing 1 kilometer. I'm looking at the function. 3 plus t, and the rate of change of this function is 1. It's a baby step. You should think, but after this lecture, you should understand the derivative. These notations means that rate of change of something. And by concrete example, in daily life, you can imagine what is the rate of change of something. Or we have boil of water. This rate of change of height in floor is 1 height, 1 meter in time. What does that mean? My rate of change of increase, my height increase per unit time in 1 meter. Okay? What do you understand is basically that. I hope you enjoy the lessons. I hope you understand what is the meaning of derivative. Whenever you see